Hi guys, good afternoon. Hope I am audible. Just give me confirmation. We can go ahead and start discussing the things then. Am I audible, guys? Okay. Okay, well then, guys, let's get started. Okay, welcome back to this series of the deep learning, where we'll be focusing more on the computer vision and NLP sort of things, and also on the conversational AI. So yesterday we started with the deep learning. We tried to understand, gain some insight about the deep learning and overall overview of the process of the deep learning works, right? So we also talked about the ANN, that how it resembles to the human brain and how what they exactly trying to do over here in the artificial neural networks. So we saw overall the overall idea that what is ANN and what are the different types of ANN and everything. But today's main agenda will be to deep dive into the artificial neural network to understand how this thing started, going back to the history. So what was the first model perceptron, how it was invented by whom, and what was the working at that time, and what are the challenges. Then how the perceptron become more and more sophisticated, how it is able to now solve the problems, what are the things that got added, and different concepts like how forward propagation works, backward propagation works, what are the activation function, what is optimizer, what are the issues with the loss function, how we calculate the loss of the neural networks. And we need to understand that how the neural network works, what is the algorithm that it uses to understand and learn from the loss function, that is called as optimizer, and different types of optimizer. And also we will see that after the optimizer, what are the issues with the different complex layer of the neural networks in terms of the vanishing gradient descent, the why vanishing gradient descent problem happens. And if we also saw in machine learning as well, that if there is a overfitting, then what are the methods in order to overcome the overfitting. In this case, in the terms of the neural network, we will be using the dropout layers as an special topic, where we'll be talking about how to regularize or what is the concept behind it, right? So without wasting time, let's get started then. So we also saw, whenever we speak about the neural networks, it consists of the three parts. One is input layer, hidden layer, and output layer. What it does is takes the information from the input layer. Hidden layer is responsible for processing the information which we have got from the input layer. And then after, our hidden layer can have a multiple layers as well, and it uses the graphical processing unit in order to process the thing, and then it will give us the output. That's what we try to understand. But try and understand that how the thing started back in 1943, that whenever these gentlemen, Macaulay and Pitts, they try to resemble the human brain functioning in terms of the statistical model. So the first concept was brought by these gentlemen in terms of a mathematical model. And this model only consists of the three parts. One is weights, like we'll try to understand what are weights in some coming time. But what they decided that they will create they will mimic the human brain functioning of the neural networks in the statistical model. For that purpose, it consists of the three parts. One was for weights, and where weights will be taken into consideration according to the signals. We will give a different weights to different signal. In second part, we will add all these weights, and then third part will be the activation function, which will be responsible for making the neuron fire or not. Just like we understood, just like in the human brain, where through the axons, through the dendrons, we are trying to receive the signal. Then it will go into the cell, and it will process just like the activation function, and depending on the weights or importance, it will try to fire that weight. Fire means it will try to decide whether this information will be particularly processed further or not. The similar thing they started to consist of the weights. They give weights to certain inputs, and they did the summation. Let's say H was the function which was responsible for summation of these things, and they multiply one weight divided by a particular respective that input, and summing all of them, and then passing through this theta function, correct? Passing through the theta, which acted as an activation function. And on this activation function, what it does is it just try to look at the previous threshold. Let's say in this case, the threshold is, let's say, 0.5. If the value after processing this is more than 0.5, then it will fire. Otherwise, it will not fire, or it will give you a result, or it will not give you result. But this was the concept they tried to mimic, but it failed terribly, right? So it just, this single neuron is of no interest because it just did not do any learning or anything else, right? So it can only just trying to give an input signal and whether it fires or not. That was the only testing they did, but it did not help to understand or able to work any further in order to solve any problem. So that's how the thing started. But then our godfather, like Jeffrey Hilton, he started with the perceptron things, and perceptron was also introduced, and where he introduced a concept of back propagation, right? Back propagation is a very important or super important concept that due to which the neural networks were able to analyze the situation, to learn the situation, and on the basis of that, they were able to give us the result. So that's how the thing started, and that was the first model neuron was invented. After the neuron, the first model invented was the perceptron. So perceptron, what is perceptron? So people thought that only single neuron will be of no use. So why not to make a architecture out of it, where we will be taking input in terms of the numerous inputs in terms of the neurons, and we will create a one layer which will be called as hidden layer, and that inputs will be passed to the different neurons, and it will be able to give us the prediction. That was the basic idea here. YJ, let's say they gave input 1, input 2, input 3 and 4, and here for W, which is called as weight, will be for input 1. This weight will be for input 1 and neuron 1, W11. Here it will be input 1 to neuron 2, and similarly it will create a denomination or say a syntax for different weights in order to identify the weight in terms of the ith layer and the jth neuron. So Wij for this one, let's say take 3, W3, which is again going to W second neuron, and so on. So that's how they made an input pass through different neurons. Within neuron, we already understand that there will be processing happening, and there will be giving us a result in terms of the Y. When we are taking this result, we're trying to compare this result with the actual target or actual prediction. Let's say target is in this case T, and our prediction is Y, and they're trying to calculate the difference between this. If this is matching, then okay. If it's not matching, then maybe what we have to do is we have to go back and change these weights, right? So because this weight is not able to give me a desired result, so that was the overall working, and this we'll try to understand that how this weight get added, or what is the working of these weights, how the weights are calculated. We'll go further, but just trying to explain that if this is how the first perceptron model looked like. But again, it failed because it did not understand or did not give us a robust predictions. Why we'll try to understand until unless there was a concept of the back propagation which was introduced again, and due to the back propagation also we were able to identify the situation, complex pattern, and then solve. But initial model was started with the neuron. Then they decided to bring up the different neuron, and then passing the different weights to the neuron, and then making the prediction and comparing with the target. That was the basic understanding or basic idea for them in the perceptron. But perceptron model did not even further perform very well. So they have decided that we'll create a multi-layer perceptron. So let's understand. We already discussed, right? What will happen? They will initially start with the random numbers and small weights. Okay, random numbers and small weights. These inputs will be going into random numbers and small weight for 1, 1, 1, 2, 1, 3, right? All this will be going to this neuron. That's why they said. And in each iteration, they're trying to change certain amount of weights and trying to calculate and compare the result with the target. If it's matching, not matching, then again change the weights. That was the only thing they were doing initially. Okay. So then they decided that what they can do is the simple perceptron single layer network was not performing well. So how can we make it more readable or more robust? So they decided that why not to bring some complexity in it. One way is to bring the complexity in the neural network is to add the layers. Either we can add the layers, more layers, which are hidden layers, or which is called as, first they decided to add only one layer because initially it was taking input along with the weights and it was giving us the output. That's what the first perceptron model. Now what they decided is that there could be two ways through which they can introduce the complexity, and that will be called as a multi-layer, and that they introduce the hidden layer. One way was to introduce the hidden layer, and second way was to make the connection back again with the previous inputs to update the weights, right? So that could be the two ways, but they decided to go with the hidden layer, and that's how the hidden layer were introduced in the perceptron. So this hidden layer, introduction of the hidden layer made it more complex. So we can process the information over here using the activation function, and on basis of the certain condition, it will give us the outputs, right? Multiple outputs at that time to the output layer when there is a complex problem, because previously we were saying only binary classification. Here it will be more complex problem which can be solved, and that's how the multi-layer perceptron came into picture. Okay, then moving further, try to understand that what is actually happening, how neural network works, right? So let's take this example and try to understand what is happening. Like I told you that whenever in hidden layer, in this particularly, we'll try to focus that what is happening in the hidden layer, what is the issue, and how they is taking the input and all. So that is our main purpose here. So first, initially, we are starting with X1. Okay, this X1 will be assigned to the weight 1, correct? And that will be called as W1 X1, right? It will go into the hidden layer, and again second input, which will be again X2 multiplied by weight 2, will be again going addition to this one, right? Like here, and again similarly this W3 multiplied by input will be taken into consideration, right? This is what happening. This is called as Y. Then again Y will be gone through the activation function. In step 1, what we're doing, they are just in step 1 they are just adding the weights followed by the different inputs and making the summation of it, weight multiplication of the inputs plus addition. So that's what the first part they did. What is happening in the hidden layer is step 1, just add multiplication of weights into inputs and then adding it up, right? And step 2, what they're doing is there are 2 steps performed, right? One step, just go forward, calculate what is input, assign the weights to respective inputs, and make an addition. Once this addition comes in, let's say whatever number it comes in, that number will be passed to a activation layer, like in this case, right? That number will be passed to a activation layer and the activation function. This activation function, guys, and even before, I forgot to tell you, whenever we are trying to add these weights with respect to the numerous inputs, we are also trying to add a bias. Try to understand bias as an simple input or simple constant number or small number which we are trying to add. In case if this goes 0, then the Y should have a certain number. Initially, with this concept, they started adding the bias, and this weights plus biases will go into the function Z, which is the activation function. Again, this activation function based on the threshold. Let's say we decided the threshold of 0.5. Whatever output comes, if it is less than 0.5, though, it will not go further. And if it is greater than 0.5, it will go further, right? Once this goes further, right? Because this will be the different permutation combinations which they will be doing. It goes further. Again, in second time, what will happen is, again, whatever Z value we have created, right? We are able to create this Z through the activation function. Again, this Z will be multiplied by the new weight. When the output of this layer will be multiplied by the new weight, let's say W4, and that W4 will be again passed through the activation function. And then after passing through the activation function, finally, it will be giving us the output, which is Y hat. So this is basic understanding, guys, basic working that what happens actually in the hidden layer. This is for one perceptron. There will be multiple perceptrons which will be available in this case, and they will be doing the same thing. I hope, guys, this is clear that what is step 1 and step 2 and what is activation function and all. I will try to discuss these things in detail going further. Okay. So we'll try to understand what is the importance of the weights, what is the importance of the bias, and what are the different activation for functions are there, and what role they're performing here, and what is their importance and role. So at least, guys, I think this much part is clear. Z is nothing but just the denomination given to the function output, right? Let's try and understand this way. What Z is nothing but whatever output, right? Whatever output it is giving, right? This part output is called as Z, because here what is happening? There are two steps happening. One, we are doing a summation, and it is going through the activation function, because first function was Y. Y is just multiplying the inputs by different weights, and that Y is going through the activation function is called as Z. Okay, Z could be the output of, let's say, this layer, first perceptron. Guys, we'll try to understand how to decide weights and everything. Weights are decided by the different parameter hypertuning of the parameters. When we'll speak about the gradient descent algorithm, which is responsible for these things, at that time we'll try to understand this thing. I will cover that entirely. We'll go in detail that how weights get updated in each and every steps, and how the gradient descent works. So that I will cover at that time. But try and understand this, that first thing is multiply the inputs by weights. That is called as Y. That Y will be, this Y will be again going through the activation function, which will be output of, this will be the output Z, and this Z in step again further will be multiplied by this weight, and which will again go through the activation function. Okay, Z is again, let's say this one is Z1. So again, Z1 is equal to Z, what is the output of the previous cell, and divided by the new weight, W4. And then whatever value will come, that will be called as predicted value. Let's say Y hat, right? Y hat in this way. This much part is clear, guys. Just ping me that you guys are able to understand what are the two processes which are taking place in the neuron. One step one, we're trying to add and multiply it by the weights, input multiplied by the weights, and sum all the inputs. And then in second part, we are passing it to the activation function. We'll try to understand what is activation function in a meanwhile when we'll try to discuss the further thing. These are the two steps what happen primarily here, step 1 and step 2. When step 1 and step 2 happens, then there will be a output which will be called as Z. Again, this Z will be multiplied by the new weight. Let's say, because there is a connection. Whenever you see these connections, this connection are nothing but weights. Okay, whenever we saying this connection, this cell, this particular perceptron is connected to the next perceptron, you can say certain connections, right? These black lines, these black lines are nothing but the weights, because whenever whatever output coming again from this perceptron hidden layer, that will be again given a weightage, and that weightage along with the weightage multiplication of that output with the weightage will be passing through the activation function in this case, and then the value in the output layer will be generated. I hope this part is very clear, guys, that how neural networks work. Let it be any kind of neural network. This is just we have taken a single layer. Okay, here it is single layer, but let's say there could be multiple layers. At that time, what will happen? Similarly, if all these inputs x1, x2, x3, right, all they are going into this layer, right? Let's take different colors so you guys will understand. All these inputs are going to this first perceptron in the hidden layer. Similar thing will happen in the second perceptron, which will be over here. If it is a complex structure or multiple layers, a multi-layer, multi-number of perceptron, same calculation will again happen. Like this will be called as Y2, and this will be Z2, right? Y2, Z2, again, same calculation will happen, input multiplied by different weights again, right? There will be again different weights which will be given to them. And again, the multiplication and along with the summation will happen. That will be again passed to the output. And that will be called as, let's say, Z2. And then again, Z2 will go through, let's say it has a connection here. Again, it will go through the different layers. Again, it will try to give you output. So we'll try to understand these things as we go further, but at least I think the basic idea is clear, guys, right? Everyone. So hope we can move forward now. Activation function. Okay. So what is activation function? Everyone is asking what is activation. So try to understand activation function, because I told you that previously when Jeff Hilton, he introduced the back propagation. What is back propagation? The way the neural networks are learning, right? Even before introduction of the optimization algorithm gradient descent, the perceptrons or these neural networks, they're not able to give a good result. So after that, they introduced the concept of the activation function, and then the actual revolution came into the picture, right? And what is activation function, and how even still there are every day there is a research going on, and they're trying to find out what is activation function. So try and understand what is activation function from point of view relating again back to the human learning, how the human learns, and what is the biological neuron, and on depending on this biological neuron, we'll try to understand. So what is the activation function? So we understood Dentrad, what it does is we try to bring the information inputs into this cell, right? So in cell, let's take example, right? I gave you guys example. Activation function used to determine threshold. No, not threshold, guys. The activation function comes with the thresholds. I'll try to explain. Just have some patience, so you guys will be able to understand that what is happening over here. Okay. What is happening, we'll try to understand. Wait for the moment. Try to understand what is activation function first, then we'll try to understand what activation function is doing. Okay, in human brain, what happens is whenever this dentot, some gentleman called as dentot, they try to bring the inputs to the cell. In cell, what the happen is there's some pre-processing happens, and on the basis of the pre-processing, they decide whether to fire this neuron or fire this information or not. That's what we understood. Now, what is happening is, take an example. Let's take an example that whenever there is a child, a small child, he's not aware of all the things, right? Whenever he initially starts his journey of the learning, at that time he try and experiment. When he start scrolling, he will go to different places, try to touch to different objects. So take example that this child start crawling and get his hands on a certain sharp knife, right? So if we try to touch that certain sharp knife, at that time, what will happen? It will get itself injured, right? So maybe bleeding will happen, or some sort of the pain will happen. Once this pain will happen, what will happen? Let's take example that if this pain is happening, he's trying to touch this knife. Okay, this kind of knife is there. Let's say this is knife. I'm not good with that picture, guys. So pardon me for that. Okay, if the child try to lay his hand, okay, he try to lay his hand on the certain knife. At that time, he will get the pain, right? He will be getting pain. If you try to touch it might get itself hurt, right? At that time, what will happen? The neurons, okay, neurons in that particular finger or let's say hand will get activated, and it will try to reach to the brain. Let's use different color. So neuron will get activated, it tries to reach to the brain, and some processing happen. And that processing, on the basis of that processing, obviously, there will be weights associated with it, right? With these neuron and signals. And the signals, again, not only neurons are present in the brain, guys, neurons is present everywhere in the overall body of the person. So at a time, whenever a person try to touch the knife using the right hand, maybe there could be a certain neurons which are present in the left hand also, right? So, but that neurons will not get activated, and they will have a less weightage. This weight 2 will have less weightage, but the one hand which got injured will have a high intensity of the high weights, and it will try to fire that information, it will reach, and basis of that, right? And the basis of that, there will be a reaction sent to that particular hand. And what will be the reaction then? We'll try to throw that object, or we'll try to get carried away from that certain object, because we know that if we try to touch that object, there will be a pain, and obviously this pain will cause us some injury, and that's how the neuron decided, right? So what happens is here, try to understand, there were certain other parts also which are present in the human body, but particularly only the activation, what is say, you can say the only those neurons are getting fired where we are trying to assign the more weights. Means whenever we trying to touch the object, at that time only the neurons from that particular point of part of the body is getting activated, right? The similar concept, has been introduced in the neural network, that whenever there is a higher weightage, what we can say is, what is activation? Activation function is responsible to activate whether this particular neuron will get activated or not activated. You can say in simple terms that that is the activation functions working. So why we need activation function? Activation function will decide whether to make this neuron on or off, right? That is one part. And also they try to bring the non-linearity. Okay, non-linearity, we'll try to understand what is non-linearity and everything in meanwhile, right? Whenever we try to whenever we're trying to deal with the complex problem, at that time we need to have a certain different patterns available with us. So that is called as non-linearity, because we will not be dealing only with the linear function, right? Y equal to mx plus c. Maybe we're dealing with 1 divided by 1 plus e to the power x sigmoid function, maybe divided with the classification problem, certain other complex pattern of the problem. At that time we have to understand the different variation in the shape of the data, different complexity in the data. At that time, this activation function will play a major role, and basic role will be whether to on or off that particular neuron or not, and also to bring the non-linearity in order to understand the complexity of the data and just to give the variation. So that's how, what activations are in human brain, what is happening. That particular neuron which is there in the human entire body parts of the human, that neuron is getting whether activated or not activated. On the basis of that activation, it fires the signal, right, to the brain. So that is same thing here happening here in the mathematical model, that they're trying to mimic the same activity. That activation function is also here, which will decide whether to fire that particular information further or not, and also to bring the non-linearity. So correct, guys? We are clear what is the basic idea behind this activation function, or any doubts, guys? Still, just ping me, guys, quickly that you are able to understand the basic concept, that at least activation function is responsible kind of a function which will try to decide whether to fire this information further or whether to activate that particular cell or not, and also bring the non-linearity. Hope you guys understood what is activation function. No? Or still any doubts? You can just quickly ping me, guys, so we can go ahead then about the activation functions. All right, so okay, people are saying they're okay, understood. So let's go ahead then. Okay, guys, thanks for the confirmation. So we can go ahead and try to understand more detail. Okay, neural networks, what we're doing is we're trying to achieve the different weights, right? With different weights, we are giving information to information in terms of the inputs, let's say x1, x2, x0, x1, x2, and we are assigning the weights. What is happening in the neural network? We understood two steps. One is let's take the marker and trying to understand. That step one we spoke about, right? Guys, I will tell you how it is considering weights. Don't worry. When you try to understand the gradient descent algorithm, at that time you'll try to understand the things. Just hold on your horses for the moment. So we'll try to understand one by one concept at a time. So we are not able to. So we will be able to understand everything. So we'll not get confused. So what is happening is here. So activation function is, let's say, it's kind of a say gate, right? It's a kind of a gate. Whether information is passed, whether I will decide based on the threshold. Okay. Based on threshold, whether I can pass this information further or not. So whether I'm going to fire this information further or not, that is the basic understanding. So how we can understand is that it also, what do you mean by fire? Means it will decide whether to keep this neuron active or not, further information passed or not. Okay, so that different activation functions which are available, which try to understand in meanwhile, but try to understand the basic idea is that whenever you're trying to assign the weights and giving inputs, the two steps are happening. One is summation of the weights along with the bias, right? Weights and biases, we understood about this thing, and then this passed to this entire thing called as y, right? It went to the z. We understood z. Z is what? Activation of y. So on the basis of the activation function, it trying to bring the values between 0 to 1 or between 1 to -1. So by doing that, and whenever they try to bring the value between 0 to 1 and 1 to -1, it will keep a threshold. Let's say threshold is 0.6 at that time. At this time, let's use different color. Threshold is 0.6. Whatever value comes in, if it's more than that threshold, then it will pass on further. Otherwise, it will not pass. B is again, guys, bias. You try to see that whenever we in Y we're trying to, what we are doing here, we're taking weights multiplied by the inputs, right? And we're trying to sum them. So apart from that, we are trying to add some small amount of constant value. Some constant will be added in addition to these weights, just to make the smaller changes. What if tomorrow, whatever weights and inputs I have processed, this multiplied by, let's say these are 0, 0.2 or 0.6, this entire term will become 0, right? At least I should have some information with me, some sort of number with me, which is like small number, like say 0.01 or 0.2. That kind of constant, I will try to keep it with it, so that it will be better for the calculation, because this will be not one cell, there will be multiple cells available, right? We saw about multi-layer perceptron, there will be hidden layer, multiple cells will be available, and all these inputs are passed to all different cells. At that time, if this entire calculation goes to 0, just theoretically try to understand hypothetically, if this goes to 0, at least I should have a certain number with me. For that purpose, I am adding this bias. This bias is nothing but a small constant value, a small value, okay? A small constant value, let's say constant K. I'm trying to add it. That is B, guys. Okay. So I hope now everyone understand what is the function of the activation function. What is the working of the activation function? Our automation function try to normalize the data, try to bring between 0 to 1 or -1 to 1. How it will try to understand these things, and why it is important, that we'll also understand. Okay, let's take example, guys. Very interesting example. Now we'll try to take example to the real life, and because of that, you will be able to understand what is happening over here and why we need activation functions, or why we need to normalize our data, right? So let's say that what you are doing, you are a Netflix company, right? You are a Netflix company, OTT platform. You are running a OTT company called as Netflix. Now you are owner of Netflix, and what we have to do is we have to decide that what will be the top 5 movies, right? Whenever you go to any OTT platform, you say top 10, right? Top 10. These are the top 10 for the month, week, or so on. Current trend, this is the top movies. And this is how it will try to display, because whenever you go to these websites, or whenever you go to this OTT platform, it will try to tell you that in the film section, these are the top 10 films, everyone who is watching, right? There will be second option, everyone who is watching. Or you can say this is the top 5 web series which are currently being watched on this platform. So did you guys ever imagine that how they try to come up with this top 10 or top 5 list? Okay, what they will do, what could be the possible way? Just guys quickly ping me that how you think that they try to rank them for the top 5. What all the criteria they may be considering for the ranking. So I can understand that at least you guys have a basic understanding of how the ranking works, or maybe what are your thoughts about how they're trying to rank the things. So just guys quickly ping me couple of the criteria, what you think is possible, that on the basis of this criteria, they're trying to rank the systems or rank these movies or web episodes. Just give me your input that what is the understanding. Sort out a variation in movies. Yeah, sort out the variations, but give me a concrete example, like on the basis of what criteria, concrete criteria, which I can able to measure the criteria, right? Measurable criteria, that how they are going to rank the movies on the basis of the different categories which are available. So what could be the concrete criteria? Filtering, yes, filtering is happening, but how they are trying to filter? How, on what will be criteria? Time, picture quality. Yes, guys, picture quality is there, time is there. Yes, but what happens is picture quality will be always be good for all the movies which are there, right? All will be high resolution HD movies, ultra HD movies, 4K with dimension. Sir, can you please explain more about what kind of dimension you are talking about? What dimension you mean to say about the dimensions? Furthermore clarification, what kind of dimension they are trying to use? Simple task, guys. I think you guys understood that we want to rank the movies on Netflix, you are owner of the Netflix, they say, and now you are a super rich person and you want to increase yourself. You want to make a ranking on what are the top 5 movies for the week. So what you will do? What criteria you will try to understand? Simple criteria, guys. Try to imagine that if you want to rank a popularity, motion of the cameras, guys, don't try to go into the technical part of the movies. Just try to understand from the user perspective. Try to focus on the user, and on the basis of the user, try to tell me the criteria, that what could be the criteria through which we can consider this ranking. No, not from the technical side, just from the user side, that how the way user can interact with these movies. Try to come up with the criteria on the basis of that. Story, correct, right? So story is correct option. That what is the story? On the basis of the story, what you can do? Categorize whether this is action movie. Number of views, correct, exact, guys. Number of views is one of the option. If I am getting more views based on the age, how movies are based on the age, right? Moral values also possible, or based on the categories also possible, because what I can do is I can categorize them: action movie, right? Science fiction movie, or this is something romantic movie, or could be some way I can say that these are nominated for the comic movie also possible, right? These are nominated for the Emmy Award or Gram Award, or they are getting Golden Globe Awards. So that kind of criteria can also we can try to consider, right? So what happens is, let's take example that I have decided that I will do only ranking on the basis of the views people are giving me. Guys, try to understand what is views. Views means people are saying that, okay, this is a good movie or this is a bad movie, right? What I can do is just clarify everything and start with the beginning. If you want to rank a movie, so people are giving positive views. Select positive views. I will give a positive number, +1, +2, +3, like that, right? For this movie, particular movie. One positive view, I will say positive ranking. And if someone says negative thing about it, I will give a negative ranking, -1 or -2, +2, +3, right? And what I will do, I will sum up all these numbers. And if this comes in positive numbers, let's say it comes in as 5, positive 5, all the addition comes in. Hypothetically, I am taking. So I can just say that the score for this movie is 5. Similarly, I can take different movies, and on the basis of the positive and negative feedback, I can give a rating numbers, negative numbers for the negative feedback, positive numbers for the positive feedback. Again, I will give a high weightage to lovely movie, superb movie, according to the intensity of the views. I will give a different weightages, right? Trying to understand how the weightage is getting created here. So if I say it is a lovely movie, superb is obviously more than good movie, right? If I say it's a good movie, so I can give 2 rating, score 2. If they're saying superb movie, obviously I will give 5, because superb is more than somewhere more than good, right? So this way I try to sum everything, and then on the basis of that, I will try to achieve the score. If this score is positive, I can say this is good movie. If a score is negative, they say this is a bad movie, right? And whosoever ranks highest on this number will be the top one, right? Whosoever trying to getting a highest number will be your top 1 rank, that movie, right? So that's how they try to get it. But now try understand again the issue with this ranking, right? So what could happen is, now I decided that on the basis of positive and negative, I will try to give a positive or negative numbers. I will sum them, and the basis of the sum, I will try to achieve a score, right? I try to achieve score. On the basis of the score, actually reviews based on the different process of perspective, patterns, and sense of receiving. Yes, correct. That is also possible, but we're trying to generalize the example here. So try to understand that what I am trying to achieve here is I'm trying to tell you, so why activation function is important. Okay. So that is the main thing why I'm taking this example, that why activation function comes into the picture. Now we understood that if higher score, high ranking, low score, low ranking. So try understand, if people say that this movie is good, okay, if they are giving me a feedback like this movie is good, but I will not recommend it to anyone. So again, this is ambiguous statement, right? So I am not able to understand, right? I am not able to understand whether this statement is on positive side or on the negative side. What we'll do at that time, right? So you are getting score on the scale of -infinity to plus infinity. But if you get this kind of reviews, which are where you will not be able to understand that what is happening, that whether it is on positives or negative side, that will be problem. In order to take care of that problem, what we can do is we can try to bring this score, which is ranging from minus infinity to plus infinity, between 0 to 1 by using the probability. If I apply a probability function here or take a log of it, so I can bring values between 0 to 1 of probability, and then on the basis of the probability, okay, on the basis of the probability, if probability is more than 0.5, I can say it is positive, or probability is less than 0.5, I can say it is a negative movie, negative ranking, right? So this entire function, what we saw, right? This entire function, what we saw about bringing this entire concept of negative to positive between 0 to 1 range, that is done by activation function, guys. So this is the main role of the activation function. So what activation function I told you, they're trying to bring the information between range of 0 to 1 or minus 1 to 1. You understood why we require information now between 1 to 1, 0 to 1 or minus 1 to 1? Because on the basis of the ambiguous reviews or certain time, whenever I'm trying to classify the things, I can use the probability, right? I can use the probability on the, or similarly at the time of the image classification. Sometimes what happens is I can say this particular object is also looking like human, or that particular object is looking like monkey also, because the neural network, what it will do, try to take the high level overview, because we are evaluated from the monkeys. So for very poor neural network, monkey and the man could be same, right? Obviously there will be different features, but for overall level structure is same somewhat, but we don't have tail, it has tail. Apart from that, but overall the structure is same. At that time, what you will say, probably this person in the picture is man or maybe a ape, right? Ape is more similar to the person ape. So at that time, what we can have, what we can do is we try to bring the different activation function. On the basis of that, we try to introduce the probability. So what is the probability that this person is this picture belongs to a man or a ape? So highest probability will be the classification at that time. So now you guys are trying to relate, right? Why we need activation function. Hope this example is clear, guys. Just quickly ping me that now you're able to relate why we need, even we took two examples, right? One is how we can do ambiguous ranking and how we try to classify the things now. Just couple of more yes, no, guys. So then we will be, once you are fine with the activation function, I will try to understand certain activation function which are available. So, but now you guys are understood what is activation and why it is important. I can see only one yes or no too, guys. Just more than 400 people are there. Just quickly ping me. So if you, most of you are able to understand, then I can go ahead with the topics then. If you are not able to understand what is happening with the activation, you forgot about the back propagation on optimizers and everything. So every concept, each and everything, what I'm trying to tell you guys here, it is very super important. If you miss one of the concept, maybe you later on try to understand. You will find it difficult to relate to the certain things then. Okay, guys, and a couple of people are saying now, yes, I think. So hope the example was very clear. So you now understood that what is activation function, or they're playing a role in the real time. Let's move further. So before we even start with the different activation function, I'll try to explain you what is activation function, one or two examples of the activation function. The popular activation function example which we saw was the sigmoid right now, right? What do you mean by sigmoid is, I try to tell you what is sigmoid. I'll try to take a different color so you guys can understand. Sigmoid function, what it does is, here it is 0, let's say. The sigmoid function's graph look like this. And this is between 0 to 1, guys. So sigmoid, and this is somewhere negative scale. This is -3, okay, -2, -1. This is minus scale, and this is positive scale. This is 1, 2, 3, and 4. What sigmoid function says is, formula for the sigmoid function is 1 divided by 1 plus e to the power y. We understood what is y. right? Why? This is why summation of all the weights and the respective inputs. Weights means, sir, quality of the data, small pieces. No, guys. Quantity of data small. No, it's not like that. What we can say, you guys understand that. Let's take example of the weights now. Everyone is trying to pop up into the weights question. So try to understand this way. I will give you a very practical example. If you want to buy a new car, okay, the situation is that you want to buy a new car, and for buying a new car, what will be the options? There are multiple options, multiple makes available, right from the foreign makes to Indian makes. But what you will do, how the decision making process will work, we'll try to understand. What you will do, obviously, if I am Vikas goes back to his family member, clear out everything. I will clear everything, and here I will try to consider this situation. I will try to relate to a real-time situation, then we'll try to understand what is weight. Okay. I want to buy a car. Vikas wants to buy a car. What all option available? I can go for foreign make cars, or I go to indigenous cars. Also option available, right? So how the decision making process will start? The moment I decide that I want to buy a car, I will go to my parents. I'll go to my parents first. Obviously, I will go to wife. Every person listens to wife more than his parents, right? Go to wife. Or obviously wife is behind you all this time, that now buy a car. Okay, so whatever your wife's choice is there, right, about this car's model. So this is, let's say, choice C, and then you will also go back to your parents. You will ask what is their choice, which car they prefer, right? Then you will go to your friends, and you try to inquire about, okay, what is the trend nowadays, guys? You are already using certain model. How is the performance, right? You will also try to go to certain reviews, websites, and everything, and they try to speak about the different latest advancement and latest features and updates which are available. So this way, what you are trying to do is you are trying to reach to the closest circle of your people, and whatever information is available. On the basis of this information, you will take a right. You will take a final decision that whether you want to buy a car or not. And even on that buying a car, you will try to understand that which car particularly you want to buy basis of the performance. But now, in order to buy the car, what we did is we had a different opinion from different people, wife, parents, friends, right? Websites. For all these, let's take different color clearly, right? For this decision making, you went to different sources, right? Went to different sources. Let's write wife. You asked your wife, you asked your parents, right? You ask your friends, you did a research on the website, you googled it and everything, right? And the basis of that, now let's say the decision making will happen, right? So consider them as the inputs, right? Consider them as input, because you are taking input from them. This is x1, this is x2, this is x3, and this is x4, right? So whenever you're trying to take these inputs in order to make any decision, you're taking input from wife, parents, and friends. But now coming to the main question. So weightage, now importance, how to divide importance for these inputs. So whenever, whatever your wife is saying, it will be high importance, right? Let's say it will give a 60%. 60% importance you will give to wife, because if you're not trying to buy a car which your wife likes, probably, so entire lifetime of that car, you will get cursed by your wife, right? So in order to avoid that, you will obviously listen to your wife, correct? Then next percentage you will give to your parents, closest to you, right? And you will give a less percentage of weightage, let's say 5% weightage to friends, or 5% weightage, and this will contribute to entire 100%, right? 100% of the weights. So now you are giving importance, right? Different when we are making a decision, you are giving importance to different people in certain criteria. So that importance is called as weightage, guys. We are giving weightage, right? So that is weight. First weights, that is called as weights. So different inputs associated with the different weights. So according to the situation, you are giving high weightage to some inputs, high weightage to some other inputs, right? Sometimes moderate in weightage to other things. But when we'll go in detail, we'll try to understand everything, right? Meanwhile, try to understand means weightage means looking at this example, whenever you try to buy a car, we get different inputs. To different inputs, we are giving importance criteria. So that is called as weights. Now it is clear, guys, what is weights? At least basic idea what weight are doing here along with the inputs. That why whenever first step, whenever we try to start the processes, we try to take the weightages, multiply them to the inputs, and then we trying to sum them. That is the first step. That's why everyone is doing. Because again, why we are doing this neural networks? Again, we have to make a decision making. So that decision could be classification, could be clustering, could be segmentation, or could be trying to predict certain value, right? All this decision making, and for that respective decision making, we are taking respective inputs and multiplying to the weights, and that is how the weights is. Clear? So now we also understood what is activation function by taking the example, real-time example, that if you want to rank a movie at that time, if you get ambiguous thing, so it is better to convert these values, right? Minus infinity to infinity between certain range, and then depending on the highest probability you'll receiving, you try to make a decision for the ranking. So similarly, try and understand that first and foremost, very important or very famous function which is available here is sigmoid, and sigmoid, called as sigmoid, right? Most of you might have heard about it. Sigmoid function. Let's say this kind of sigmoid. Sigmoid function, what happens is, sigmoid function lies, the graph of the function looks like this. Okay. Let's try to draw it clearly. Okay. This graph will look like this for the sigmoid. This will be 0, this will be positive scale, okay, and this will be negative scale. This will be between 0 to 1. This is -4. This is positive 1, 2, 3, and 4. And the formula for the sigmoid is, I told you, 1 divided by 1 plus e to the power minus y. That is the equation for the sigmoid. Okay. So what will happen is, and what is y? This is our y, summation of the weights along with the bias, and that we are trying to pass through the activation function, right? Step 2. Here, step 2, right? Step 2, we understood what is step 1. Just try to sum the weights, and then step 2 will be pass this summation of the weights to the activation function. So sigmoid is the activation function we're trying to understand. Okay. So sigmoid, what it does is, whatever y is there, whatever value the y is coming up, right? Whatever value is there, we try to replace that value here. 1 divided by 1 plus e to the power minus of that value. Let's say value, let's say 1. Whatever calculation you will do, all this calculation will try to fall between 0 to 1. Let's say the value of this y came to point around something, hypothetically 0.06. So we decided the threshold that the threshold, let's say 0.6. This is the threshold, 0.6. On the basis of this 0.6, if my score is more than 0.6, I can consider this as a positive. Less than that, this as a negative. So that is how sigmoid will work. You bring any value, which is from minus infinity to plus infinity, to try to bring between 0 to 1, guys. So this is the formula for the sigmoid, and by using this sigmoid, we understood why we need to bring them into the 0 to 1. Because if it is ambiguous, I need to calculate classes. If it is multi-class classification, I need to come up with the probability, multiple probability associated with that particular object, right? So that's how the sigmoid function works, and that is the importance. You provide any positive score, any y, and it will try to fit in between 0 to 1. And we also understood that y need to bring these infinity values between 0 to 1. So on the basis of these probabilities only, we'll be able to make the decision for the classification. So this is sigmoid, guys. Similarly, we have a tan H function or ReLU function, let's say. Try to understand what is ReLU. Again, how it is trying to bring the values between 0 to 1. So next function will be ReLU, rectified linear unit, ReLU. Okay. LU. Again, this is very famous function, guys. Sigmoid and ReLU. These are mostly used. That's why I'm trying to take these things into more deeper and try to tell you that how the working of this ReLU is. So ReLU, what it says, what the formula for ReLU is, it says max of, this is max of 0 or Y. Okay, max of 0 or Y. Let's take different color. So this is 0. Okay, so what is saying? Max of 0 and Y. Again, we know what is Y. This is Y. So whatever values of the Y comes in, let's write it clearly. Right? So I'm trying to draw ReLU function on the graph of the ReLU, how it will look like. I'm trying to tell you. Okay. And the here is the 0. Thing in 0. This is ReLU. Linear rectified unit, right? ReLU is rectified linear unit, sorry. Rectified linear unit, that is ReLU. Okay. And the formula for the ReLU is max of 0, Y. Okay, that is the formula for ReLU. Max of 0, Y or Y, 0. Same thing. So whenever value of Y, which is here, we try to take that value, whatever is the higher, that will be the output. Okay, let's try and understand. This is the positive scale. Okay, 1, 2, 3, and this is negative scale. Negative, this is positive side. So if my value of Y is 1, I will pass this Y to the activation function ReLU, and then what ReLU says, max of 0, 1 in this case, right? So max will be 1, so it will be 1, right? Like this. If it is 2, it will be 2. If 3, this will be 3. So that is how it works, right? What max of whatever 0, 1. Again, there will be a certain other like parametric ReLU, exponential ReLU. That will be between 0.01 to Y. What is max of Y? This kind of values are available, and that's how they're trying to bring or linear normalize the data between 0 to 1. So these are two popular things, guys. For ReLU, again, there are different variations available: rectified linear unit, parametric ReLU, exponential ReLU, and some other ReLU. We'll try to go through briefly through them. But try to understand, guys, these are very two super important things: sigmoid function and the ReLU function. And using these functions, we try to say that activation function, we try to normalize the data between 1 and 0 or minus 1 and 1. And why we need between 1 and 1? Because to calculate the probability. On the basis of the probability only, whenever there are these ambiguous kind of let's say reviews, or we trying to classify certain things, at that time, that is the possibility that basis of the probability, let's say what is the higher probability. On the basis of this higher probability, we'll try to say that this is a particular picture, this particular picture belongs to this person, or this kind of object is available in the picture, or this kind of ranking will be going for this movie. And on basis of that, could be the real application of the activation function. I hope, guys, now what is ReLU and what is sigmoid, you guys are now clear. I think what is ReLU, what is sigmoid. We'll try to look at certain other examples also. What are the other activation function available? But I guess you guys are now very well aware that why we need activation and what is practical use of them. So I understand some other function apart from the ReLU. Okay, apart from the ReLU, then is tan H, which will give you a value between -1 to 1. For linear equations, obviously the range will be between -infinity to infinity, because we are trying to predict the continuous value or discrete value, right? Continuous value f of x equal to x, right? And this graph will look like this one, because from minus to plus, right? So, but for the classification purpose or for certain other purposes, there will be different functions. We already spoke about sigmoid, which lies between, right, 0 to 1, and the graph looks like this, right? This one graph, 0, and this is the equation. We also spoke about the ReLU, right? ReLU is max of 0, 1, and this is how either it's 0 or this is 1. This is how it will look like, right? And tan H, again, tan H is a function, okay, hyperpoling tangent. It will try to give you what is the formula, e to the power x, okay, e to the power x minus e to the power x divided by e to the power x plus s. Now, what is e to the power x? X could be not x, actually y. What is y? Again, it is a summation of weights and inputs. So that is y, and that y will go into fit into this formula, e to the power y minus e to the power y, and same addition of e to the power y plus addition of e to the power s, which will be able to give you a value between -1 to 1. Again, rectified linear unit, we are understood what is ReLU. That is one more version of the ReLU. One more version of the ReLU will be rectified linear unit, which will be giving value between 0 to infinity. And then sort plus again between 0 to 1. Guys, try to understand. So whenever we are using the multi-class classification, right? Multi-class classification, at that time, the probability associated with the different classes will be given, right? What is the probability for, what is the chances that whatever, let's say I am giving you a picture of Vikas. So that could be possible that I am trained my neural network on different persons, and on the basis of that, try to match whether this person photo belongs to Vikas or not. At that time, it will give you a probability that what is the probability that this picture belongs to Vikas, or this particular picture belongs to Tom Cruise or Chris Hemsworth or some other person, right? This kind of bifurcation it will give in multi-class classification. At that time, what we need is, we cannot just go ahead with this normal sigmoid function, because whenever we try to sum, okay, so whenever we try to just clarify everything, whenever trying to sum the probabilities, okay, probability 1 that this picture belongs to Vikas, probability 2 that this picture belongs to some other person, and probability 3 that this picture belongs to some other person apart from this 1 and 2. So whenever try to add these probabilities, right, in case of multi-class classification, whenever we learn the probability, what it says that probability sum should be always between 0 to 1, right? So when we're talking about the multi-class classification, at that time, when we use a sigmoid function at that time, and we try to create the probabilities, it will not try to give you a sum between 0 to 1. It will be more than that. Just to bring that probability between 0 to 1, we are using the different functions like softmax, which is again giving you the log of 1 divided by 1 plus e to the power x. But again, it is not giving you with the normal sigmoid function. Again, it is with the different criteria as it is trying to give you. Let's say you can also try to calculate using the soft plus also. So there are other options also. And so why we need other function is like, when case of the multi-class classification, we need to sum up all the probability between 0 to 1. So for that purpose, there are certain other algorithms available, or say other activation functions are available. Okay. So leaky ReLU is again part of the ReLU, but it is trying to give you max of between 0.01 and x. X is again y. 0.001 or y. What is the highest value that will try to give you accordingly, and so on, guys. So these are certain popular activation functions which are available, and also we saw that why they are important. I hope, guys, now different activation function, it is clear. So we'll try to move to the loss function. What is loss? What do you mean by loss? Just before that, guys, quickly just ping me that you guys comfortable now with the activation function, of what all different activation function, and how we can use the different activation functions for the different purposes. So once we are aware, now we can move to a next concept, which is called as loss function. Just couple of more pings, and then we are good to go then. So it could be breather for me also, right? For 1 minute. If I say yes or no, just ping me quickly, so we can try to understand what is the loss function and what kind of loss functions are available, right? All right. So I guess we can go ahead now. Yeah, okay, guys. I understand what do you mean by loss function? Okay, guys, thanks for the confirmation. So now what we are doing till now is, we try to understand how input layer is coming. Okay, how the input is coming. Once the input comes in, what happens, like aggregation of the weights and sum, and then it is passed in step 2 to the activation function. When we pass to the activation function, again, maybe it is going through the different layers, right? In this case, we are giving input data x1, x2, and x3. It is going through the hidden layer 1, hidden layer 2, right? H1, H2, and here the weights are given, different weights are given. Try to take different color. The different weights are given, right? Is given different weights. Now we understood what is weight also. On the basis of again two-step process, right? Two-step process which is happening in each and every cell. Okay, summation, comma, activation. Activation function. On the basis of that, different weights are there. This is the weight 4, this is weight 3, and this is weight 1, and accordingly all. And we grade the final output as a prediction, right? Correct? This part is clear now, right? So we get a final prediction. So when we try to compare our final prediction, so y predicted, right? Let's say y predicted is my output out of this. This is y predicted is my output. Okay, in this case, output is y predicted. So when I say y predicted, I will try to compare this with the actual value, right? I want to understand this y predicted and compare this with the original y. What is hidden layer? Okay, guys. That's why I was trying to tell you guys to try to concentrate. What is hidden layer? First layer will be called as input layer, where we're trying to give a input. Why 2 inputs and 2 outputs? You can take multiple, no issues. Just for the example or simplicity you are taking, you can take multiple inputs, multiple output, and multiple hidden layers. No problem. That's why we called it as multi-layer perceptron, right? Where we are taking multiple layers. So input we are getting through the nodes, and in between inputs and the output here, right? This is my output. I want to perform some processing. That processing will be taken care by certain layers. Let's take different color. This in between processing will be taken care by some other layers. Those layers are called as hidden layer, and this is output, guys. I think hope now this is clear. Hidden layer functions as an calculation or analysis of variables in form of processing. Guys, we till now we understood that in hidden layer what is happening now. We are just taking weights, multiplying them with the inputs, and we're trying to process, take output, again pass it to the next layer, right? So till now, whatever you guys have seen, that concept, okay? Let me clarify everything. Just clear everything and start with again. Okay, this is my input layer, let's say. My input layer. These are my hidden layers. I'm getting input, making two-step process. I'm going to answer your question. That's why I'm trying to explain these things, Sumant. Okay. So I'm taking input, passing them to hidden layers. In hidden layers, two steps process happen. One is summation, weights and inputs, and then is activation function. Okay. And then again, our next weight, this output of this layer will be given to this next layer. Here again, same thing will happen, and then it will be multiplied by new weight, let's say 4, and then the output will come right here. So what is happening here? We are just trying to take the weights, multiply by weight, perform activation, again pass it to next layer on, again they will process. The entire processing happen. This concept of processing from layer by layer is called as forward propagation, guys. Forward propagation. Okay. Now understood what is forward propagation? Forward propagation means we are trying to take input, perform calculations, right? Till now, we are trying to only perform calculation. We are not analyzed anything. So try to understand the process first. So first process, what we are trying to do is we just taking inputs, assigning weights, and try to perform the calculation as of now. But later on, when we'll try to understand what is loss function, at that time, now you will try to realize that this time in forward propagation, we are just trying to perform the calculations. In backward propagation, when I'll talk about the backward propagation, when we predicted something, at that time we'll try to understand that till now neural network has not learned anything. It's just trying to perform the calculation. That's it. It has not learned anything. It is not even started its analysis of the variables or something, that sort of things. Just trying to take whatever you are giving and that trying to process it. That is called as forward propagation. Clear, guys? What is forward propagation now? So it has not started its analysis part yet. Analysis part will start when it will start with the backward propagation. Now we are moving in this direction, right? Input to output. Then what will happen is, in next step, we try to go back from output till input layer. In next step, we'll go back from output till input layer, and we'll try to analyze what is happening, why there is a loss. So that at that time, it will start the calculation or analysis. Clear, guys? I hope I am able to answer you things. And just quickly ping me that what is forward propagation now. You guys are clear with the forward propagation. Forward propagation means nothing but take the input, multiply, two-step process, and try to forward that information, and going layer by layer, going through layer by layer. Correct, sir. The ma'am, sir, whosoever now saying this, Reddy sir or ma'am, I don't know. Just the process, right? We are performing the calculation. Okay. We are just performing the calculation, and we are giving the output. Output is Y predicted. This process is clear, guys, everyone. And that is called as forward propagation, right? That is called as forward propagation. Guys, backward for updating the weights. Correct. Just hold on your horses, guys. So everyone is on same page now. So at that time, we'll try to understand what is back propagation, because I will dedicate a separate time for the back propagation. Then we'll try to understand what is happening with a single layer, multi-layer back propagation, and how the things are working and how the weights are updated. We'll talk about it now. But at least give me a confirmation now. You are able to understand what is happening initially. Initially, we are taking the inputs weights, and then we are trying to multiply them with different weights. Then processing happening, and the output is predicted. One way, one cycle is complete. One way, forward way, right? Hope everyone is now aware what is forward propagation. And this I will try to make it more brighter. This arrow is complete now. One cycle is complete. We understood what is activation, what is weight, what are cells, what happening in this particular perceptron, what kind of calculations are happening. Now one iteration is complete, and we try to predict the things. We predicted. Now what is our result that has been predicted? This process is clear, guys. I can see only one yes. Just couple of more people, so I can understand everyone is clear and there are no confusion. If we are very good with this concept now, then only we will be understand the reverse cycle, that how the things will work in the reverse cycle. So guys, more than 500 participants. Wow, what a count. But in chat box, only couple of them are active. Why so? Clear. More, couple of more clear, guys. More pings, and then we can start ahead. Come on, guys, be active. Try to ping, make interaction. Otherwise, it will become very monotonous for me, because I am just speaking, going on speaking. And what is the use if you guys are not able to understand the things then? Okay. So quickly, within 1 second, ping me that whether it is clear or you still need any explanation, guys. Or any topic is ambiguous, you still need any clarification on any certain topic. So it is really a very interesting and exciting thing, guys. Try to understand this and try to go with the flow, and just ping me correct whether you guys are now comfortable now till this portion, till this part of how the things are working in the first iteration. So I'm not going to charge you guys for pinging anything, right? So quickly, few more people just ping me that clear, or if you particularly if you think that there is any issue now understanding the things, whatever concept you have discussed, whatever maybe weights, activation, input layer, what kind of two processes are happening. So maybe I can quickly give a couple of minutes before we start the critical portion, that is loss, and how we go back to this loss, and what are different loss functions available, what is optimizer, and how we can do it. I think I am getting go ahead. So I will start explaining the loss function now. Hope everyone is clear. Okay, guys, thanks for confirmation. And let's try to understand what is loss. Any PDF is there for notes or revising in self or recording? Yes, guys, this entire presentation and everything I will try to provide, make you available, right? So don't worry about the notes and all this presentation and everything. It will be made available for you guys. Just try to concentrate on the concept that how we are moving forward. If you try to miss anything, and again, it will be difficult for us to understand. Okay, try to concentrate now, guys. That once we have completed this process, and what we did is, this is called as forward propagation, FP, and using this forward propagation, we achieved our result, y hat. Okay, once I receive y hat, okay, then what I can do is I can try to calculate the loss. What do you mean by loss? Loss is the difference between actual value and the predicted value. Okay, guys, let me take the different color. So what is loss? Loss is the difference between actual and predicted. Simple, right? So if you can say this loss here, what they're saying is y predicted and y actual. That's the difference between them is called as loss. When we are talking about one single data point, one instance, it will be loss. And when we are talking about summation of everything, all the instances, right from I equal to 1 to n, whatever data set is available, that will be called as cost function. Why cost? Because that is the cost for prediction of all the variables, all the data points which are available. So for single instant, it is loss. For entire data set, all n number of prediction, we try to predict them, and then whatever summation of this individual losses are there, the summation of that will be cost function. Clear, guys? So what is loss? Loss is again this is the difference between the actual and predicted. So we try to compare that during this process, I was able to do a forward propagation, due to which I was able to predict y hat. Now, let's say I'm supposing that I will get 1, but I got 0, right? How we know actually why? Because we are giving it to, because let's explain this way. If I am giving image, and this is image of Vikas, okay? Try to some funny picture of me. This is actually Vikas, and this is the image I am giving. Whenever I am giving image, I am labeling it, right? Label, I am giving label that this belongs to Vikas, right? I am giving labels that this picture is for Vikas. Then there will be another picture with different angle. So I will give it again Vikas 1, 2, 3, 4, 5, and then I will feed it to the network. So I am telling my network who's Vikas. And again, if I am telling some other person, let's say Tom Cruise, this is Tom Cruise, I will saying this is Tom Cruise, T. Okay. So I know actually what is actual or what is not actual. So that is actual Y. And if this person or this neural network, he predicts Vikas as a Tom Cruise, so that is the prediction. This is wrong, right? I am expecting 1, he gave me 0. Clear, guys? Hope this is clear now. So that is loss, right? Because I am giving labels. So that's how. Clear? So I know what is actual and what is not actual. So we understood what is loss, and what is our main aim, guys? To reduce the loss. That is the main thing we are trying to perform here, right? So we calculate loss and we try to reduce the loss, and that reduction of the loss will be done through the backward propagation. Backward propagation, because again from the prediction we are going layer by layer. This is L2 layer, this is L1 layer, this is input layer. So again from the prediction to the all the layers backwards, right? And that is called as backward process, backward propagation. Why I am doing all this headache? Because I want to reduce, right? Reduce my loss. I want to reduce my loss. So if I reduce my loss, then only my model will, particular network will perform better. So let's try and understand that what kind of loss function is there, and in terms of the regression or in terms of the classification, how is loss working? How the loss are calculated? Move ahead. Obviously, guys, if Y predicted is very from Y, that means my loss is very high, right? And similarly, if Y is very close, then my model is able to perform better. And if my loss function is very high, I have to penalize my loss function. That is the concept, right? We are talking about. So let's clarify everything. Let me clear the screen and try to understand how the things are working in case of the classification. How we are trying to calculate the loss. In case of multi-class classification, what we are doing is, we understood now what is neural network. This is my output layer. And this, in my output layer, there are multiple nodes, guys. Now, see, some of you are asking that why there is one node. If this is single class, that will be one node. If it is multi-class, then there will be multiple nodes, guys. Yeah, guys, attendance. Amar, please share the attendance, okay? The classification loss, right? First, we'll try to understand with the one class. Then we'll go into detail and try to understand for the multiple class. Like I told you, right? This is my output layer, okay? And this P is the probability of being class 1, right? So actually, this now it has predicted, right? Try to ignore other things. We are taking out single class only at this time. Binary classification, we are trying to understand what is binary classification. And for the binary classification, we are using cross entropy function, which is written over here in the slide, right? Try to understand what is binary classification. Using this, we'll try to understand how the loss function are playing a crucial role in calculating the loss. Let's say this is my actual and this is my predictor. Actual was 1 and predictor is also 1. Then loss will be 0. Actual is 1, but predicted is 0, means high loss, right? If actually 0, but predicted is vice versa, again high. And if both are matching, then loss is 0. This part is clear now. Both the results match, loss is 0. If both are not matching, vice versa, the loss will be very high. So what if I try to come up with a model or certain statistical formula using which I can put this loss and try to calculate my loss for the binary class. So for that purpose, we have introduced this binary cross entropy function. What this binary cross entropy function says is that you take y multiplied by log of y. What is y? Y is actual into log of y, which is predicted, plus 1 minus y, right? Y will be class 1, probability of class, right? Probability class 1. Either this is 0 or 1, the probability 1 class, then also multiplied by the predicted value, okay? And then probability of other class, right, is 0 minus 1. If I know the probability of class 1 is, let's say 30%. So if I can calculate the probability of other, right, 100% minus 30 is coming to 70. So again, the probability of second class will be 70 multiplied by the 1 minus predicted value. So in this way, if I trying to put the values, it will be able to give me a class for the binary class, loss for the binary class, okay? So y multiplied by log of y predicted plus 1 minus y into log of 1 minus y predicted. So let's say whenever I try to put, okay, just clarify everything and try to understand this equation. Whenever y remains equal to 1, right? In this case, if y is 1, obviously y0, if y is 1 here, 1 multiplied by log of this y predicted, this term will remain, and y when this term will become 0, right, at that time. So we will be able to get a probability of 1. So y is not 1, it is 0, then this term will become 0, and then we will be able to get the probability for the another class. So that's how it will work, guys. So this y predicted can be 0, known as said b is constant. Okay, guys, at that time constant is there, right? But that that was during the, let's say we calculated y. How was y calculated? Summation of weights, and good question, guys. How it is become 0? Is it for one instance? Yes. It is not for one instance. At that moment, we are talking about one instance. When we try to sum them. Yeah, Amar will be sharing, guys. Amar, please share the attendance link, guys. People are asking for the attendance.
Yeah, share it.
Yeah, thank you. So what we're doing is, here we took one instance at this moment, right? Then there should be summation. Yes, correct. That's what I was trying to tell you, that when I sum it for everything equal to 1 to n, and this will be divided by 1 by n. So this entire formula will be for entire data set. In just addition, I have to sum everything from 1 to n and multiply by 1 by n. So that will give me a cross entropy loss for entire data set. That's how. Correct. So try and understand, whenever I am trying to put a probability as 0 or 1, it will probably, if this is this part is 1, then this will become 0, and vice versa. If this is 0, this will give me some probability, and this how we will be able to get a probability for class 1 or class 2 binary case, right? Hope this is pretty clear now. What is binary classification now? So again, guys, when you are using the multi-class, at that time, we will not be using the similar thing. We'll be going for the different formula, right? Like I told you, we will not be using the sigmoid function. Sigmoid function is activation function is good for the binary loss. What if we are trying to predict, in this case, we are trying to predict the losses for multiple class 1, class 2, class 3. What are the probabilities, right? Similar example, right? At that time, if I use the probability activation function as sigmoid, it will try to give me a higher than one value. Higher than one value, which is not possible because I have to bring all this. We understood we have to bring all the values between 0 to 1. So at that time, we have to use the softmax function. What softmax function will do is, if y predicted is like this 0.94, 0.1 or 0.5, which is applying a high error rate or very low error rate, we try to bring using this function, right? E to the power y divided by 1 plus, what is e to the power y is trying to understand the probability of one class compared to the probability of all other classes. So trying to take the ratio e to the power y, e to the power y I divided by summation of for all the classes 1 to n as compared to the probability of interclass, guys, e to the power y. So it is trying to calculate the one probability with the probability of all among all. So that's how it trying to compare and trying to bring the values between 0 to 1. That is the formula for the softmax. E to the power y summation of for all 1 to n e to the power I. So that's how we try to calculate and try to bring the value, so that the total value will be, total loss will be between 0 to 1. Okay, softmax. Because using sigmoid will not be able to achieve this one. Clear, guys? Why we use sigmoid and why we not use, why we use sigmoid and why we use? Yeah, it's already shared, guys. Again, Amar will be shared. Attendance is already shared. So let's clarify everything and try to understand what all the other we were able to understand when I calculate binary class. At that time, I will use cross entropy binary function. When I am trying to do for multi-class, at that time, I will use a softmax function along with it. So what in terms of, now we understood in classification, how we can calculate. And for regression problem, like we are trying to predict some discrete or continuous number, at that time will be same, like actual. I will tell you the formula. How we can understand this. This is actual value. Let's say I can revise this in one sentence, that is the squared mean of all values, squared differences of all the values from the actual value divided by the, it's an average squared value from all the predictions, right? Average squared value. What I mean by average squared value is, I'm taking actual value 1, y1, let's say y1 actual value, and y predicted 1. Okay, and difference of that, right? And whatever is the difference, I'm trying to square them. So squaring the difference, right? Least, or you can also call this concept as least square error. Is it for regression? Yes, yes. This is for regression, because we understood for classification we are using either softmax, softplus, or we are using the sigmoid function at the time of classification. For regression purpose, we are using least square criteria, least square method. Least square method, what it says, actual minus predicted, we are taking a square, and this is for the all individual data set, entire data set from 1 to n, and multiplying by the number of elements. So that's how we are trying to calculate the mean squared error. MSE, mean squared error. Okay, this is mean squared error we are trying to calculate, because we are trying to take a mean, and what is the actual and predicted, that difference we are squaring for 1 point. We are trying to square the difference, and then we are making a summation for all the entire data points, and then we are taking an average value, that is called as mean squared error. So that is how it called as mean squared error. That is the formula we usually use. Apart from that, you can also use, guys, root mean square error. Okay, you try to take a root of this, that will be called as RMSE, root mean square error. So depends if you want to calculate the further, making differences less, and then we trying to learn the things at that time also, we can take RMSE or MSE, anything will do. Is try to calculate the loss. That is again a popular functionality for the loss calculation. So we now understood that whenever I am trying to bifurcate the thing, classify the things, I will use mainly two loss function. One will be sigmoid, another will be softmax for the purpose of the multi-class classification. For the regression purpose, I am using MSE, mean squared error. Okay, this is the square differences between actual and predicted value and summation for the entire data set. So let's move it, guys. Try to understand more loss functions which are available. Okay, for regression purpose, like we understood, we are trying to take the square values. Can you please tell which is needed to be used when? We already discussed, right? We already discussed that for classification what we'll use, and for the regression we'll use MSE. For classification we'll use either sigmoid for binary class and softmax for the multi-class classification. Even for the regression technique, we're trying to consider this one is RMSE and MSE. In RMSE and MSE, okay. So it depends, guys, on the situation, right? You can go for MSE also, but if you feel that with the MSE it is giving you a very large number, like very large number, what happens is usually, I'll take you logic. If I trying to take a difference between actual and predicted, and if it's giving me large difference by as a MSE, so obviously my machine, to understand this difference, had to perform various iterations, right? N number of iterations, let's say 20, 30 iterations. And if I get a difference which is very small, in order to discover this difference, maybe small number, to adjust that difference, maybe number of iteration may be less number of calculation, back propagation. Depending on this kind of situation, we try to consider when to consider RMSE or when to consider MSE. So that's the logic, guys. I hope this answers the questions, guys. So try understand what is L1 loss, L2 loss. Again, it is used for the regression purpose, because what we are trying to do is we are trying to take the difference between the actual and predicted. So actual and predicted, but this time we are not squaring the difference, right? We used to square in MSE, we are not squaring it, we are taking an absolute value, and we are calculating for the entire data set. That's why summation, that is called as L1 loss, or L1 penalty also it is sometimes called as. That is called as lasso and regression also there in machine learning. This works on the same techniques, guys, right? Ridge regression and the lasso regression. Similar things are they are also introduced in there, where L1 loss, which is taking the absolute difference between the error, and for the L2 loss, they are squaring it, like MSE, what we see. Okay. So apart from that, you are still seeing Hoover loss and hinge loss. I will not go into detail, guys. Just for your understanding, I have kept in. Otherwise, it will take us entire 2 hours to understand each and every loss, because there are more losses. But depending on the situation, also we try to take the differences. Hinge loss is also there, which gives you a difference like max of whether you want to take a 0 or 1 minus predicted value into the some learning rate of some kind of error, 1 minus t target into some sort of contribution or something like that, y or learning rate. That is also possible. Hinge loss, Hoover loss is there, pseudo Hoover loss is there. There are many other loss functions which are available. We try to understand them. Will not go into detail. Just for the information, I will tell you. Now, guys, we understood now what are the loss function, popular loss functions are there. Please go over this material related. Yes, guys, I already told you that I will give you material. Don't worry about it. Just try to concentrate on the topic, that why these things are important. If you miss these things, then you will may not be able to understand the entire working. Even to understand, guys, or to learn any advanced concept, you should first understand how the working of the neural networks is. All the concept will be same, like what is forward propagation, what is activation function, why you are using activation, how you are updating the weights, and how you are calculating the loss. Once you are able to calculate the loss, again you will be going through the back propagation, right? And the back propagation, how you are trying to calculate the new weights. All this process will be same for all the neural networks. Like let it be a convolution neural network or recurrent neural network. Basic idea is same, guys. Correct? So I will not directly start with the gradient descent today, because gradient descent is the algorithm using which we are trying to learn everything. But I will try to touch upon what is optimizer and why we need the optimizers. Okay, optimizer is the again is a technique using which we are trying to optimize the value of the weights and biases. Okay, optimizer is again algorithm, key algorithm, right, guys? Which is using which we are able to adjust the parameter. They are saying, what do you mean by parameters? Let's try to understand what is parameter. Yeah. What do you mean by parameters? Parameters means, what is our equation? Y equal to weights. Correct, guys. Weights. What do you mean parameters is weights? Because we have summation of weights Wi into inputs plus, let's say, plus bias, right? This is our equation. In that, trying to understand what is the weight and what is the value of the B in such a way that I can exactly, or very with less error, or with the optimal value, I can exactly predict the Y. Okay, so that my Y prediction will be equal to Y, actual Y. So that's for that purpose we are using the optimizers. Okay, and what optimizer does is, optimizer trying to give us the optimal value for the parameters. What are my parameter? Weights and the biases. These weights and the biases. If I know exact value of the weights and the biases, then I can, on depending on the X, this X, I can predict Y accurately. The how close I am to the weights and biases, that will be the more accurate model will be, and more accurate prediction will be. So that's what optimizer does, guys, right? Optimizer trying to give you the optimal values, right? Trying to give you optimal values for this parameter weights and biases, and on the basis of this weights and biases, we can create a robust prediction. That's what. So try to understand what they're saying about this optimizer, because each optimizer has a unique characteristic and advantage. So we have to understand that what kind of optimizer I'm going to use. Usually what happens is, what is the common optimizer? Is a gradient descent. Okay, gradient descent is a common normal gradient descent, vanilla flavor. Okay, so there are different flavor also now. If we can have a different flavors in the food, why not in the optimizers also, or why not in the concept of the AI also, right? So this is a gradient descent, is a vanilla flavor algorithm. Okay, vanilla flavor. In that, what we have? Stochastic gradient descent, right? Stochastic gradient descent, batch gradient descent we have, right? Batch gradient descent, stochastic gradient descent, and normal gradient descent, right? So these kind of flavors are available apart from this vanilla flavor. And apart from that, there is also called as momentum based optimizers. So what is momentum based optimizers? We are trying to bring the moment, or trying to bring some kind of sort of non-linearity by introducing the moments, right? For that purpose, we have Adam. We also have a RMS prop, which is root mean square error prop, and the ADA grade and ADA delta. Will not go into detail of everything. Okay, so it will become again an entirely new class, and it will take around like 2 hours to understand each and everything. But we will quickly try to go through the optimizers, and what we'll do is, we'll try to understand one optimizer in detail, like gradient descent. Once you understand one optimizer, then again figuring out other optimizer will not be a difficult task. So that's the aim for us, right? So today I will not start, probably I will just give an introduction, because we have only 15 minutes left, and this topic will take some good amount of time to explain, right? So how the gradient, this is super important concept, guys. I'm saying you super important means really super important. Until unless you understand what is gradient descent, you will never be able to understand what is back propagation, how the weights are getting updated. Now you guys were holding your horses that how the weights are calculated, why we are calculating weight, whether they are calculated on random basis, whether there is any systematic way of giving the weights and everything, right? All those questions will be answered over here when we talk about the optimizers. So what are popular optimizer? Gradient descent. Apart from that, we have a different flavors. Vanilla flavor is gradient descent. We have a batch gradient descent, stochastic gradient descent. We have moment-based gradient descent, Adam, ADA grade, ADA delta, and RMS prop, right? These are 5 to 6 optimizers are there, which are very popular and mostly used. And out of that, gradient descent is the main concept. So we'll try to understand what is gradient descent. So for that purpose, I will just quickly give you an overview that what do you mean by gradient descent, okay? Gradient descent, what we are trying to do in optimizer, using the optimizer, what is our aim? My aim is to try to concentrate on this picture, guys. Okay, this is a 3D picture which we have created for your understanding. Let's say you will say how 3D. I calculate 3 dimensions for you guys. Okay. This is the third dimension. Let's say. Let me use the different color. Okay. Let's say this is error or loss. We are trying to minimize the loss, right? We have to come down. This is the 0 point, right? And this is weight and this is bias, guys. So this is the main understanding, okay? What we are trying to achieve. In this 3D graph, we are trying to find out the optimal or optimized parameters. What are our parameter? Weights and biases. So what I have to do is I have to come up with such a value of weights and biases so that my error will be towards 0. So this is the scale for bias and this is scale for, let me choose another color. So this green will be for bias. Okay. This is for weight and this one, red one is for bias. Let's draw with another color. And this is my error rate. Okay. So I have to choose the optimal value for this weight and for the bias so that my error is 0. That is the main aim. That is the main task we are trying to achieve using the optimizer. Clear, guys? So what is the main aim? Just forgot about all the variations and flavors for this optimizer, but at least you guys are aware now what is optimizer and why we need an optimizer. We need an optimizer to minimize the loss function. How? By using the estimation of the parameters. And what are the parameters? Weights and biases. This part is clear, guys? Just ping me quickly that this part is clear, so we can go ahead with the discussion. So I will probably try to explain in detail, like what is history, like what is gradient descent, and how I will take an example even. So how we update the weights, like weight 1, then how we calculate weight 1, from weight 1 to next weight, and from next weight to again coming back to different weights, and how this is again super important concept, guys. So I will not probably start now because within 10 minutes I will not be able to finish up these things, but I am trying to give you an overview that what is optimizer. Yes, guys, a couple of more people, if you start responding, that will also help me to understand get the understanding that you people are, all of us are on same page. Okay. When I say there are more than 450 people available in the class, only couple of people are responding is not good. So try to give more responses, guys. So at least you guys are aware now what is optimizer, what are the different flavors. So we can start understanding from the next class that what is optimizer in detail, how the gradient descent works, and then how we do a back propagation and how we update the weight, and that's how the neural networks learns. All right. So a couple of more yes, no's, guys, or you can ask me any doubt also till now. If you felt any doubt, right, any ambiguity, so maybe just ping me quickly. I have got like 5 minutes more. So before we can start any different discussion in the next class, I will try to give a summary of the optimizer. Let's try to take some questions, right? If you are having any doubts right now about whatever topics we have covered in today's session. So I will try to conclude the session in the next 5 to 8 minutes then. Attendance link is already shared, guys, and also feedback link. So do provide your attendance and feedback, and just ask me, guys, go ahead and shoot. Ask me certain basic questions, not for the topics which we not covered. So whatever topics we have covered till now, Just if you feel you need any clarification, this is the time, guys. Ask me the questions and I will be able to answer you now, right now. Wow, I think no one is having any question. Great, you guys are already know most of the things. I can assume this, right? No one is asking any question means you guys are very clear about the topics. Still, I'm giving you a couple of more minutes. Otherwise, we can start with this further summarizing the things. Anything if you feel like asking, you can go ahead, guys. Ask me the questions. Now, if no, then don't waste. Let's not waste the time. We're trying to summarize the things then. Clear, guys? I think I'm audible and you are able to understand what I'm asking. Activation functions means the positive, means it is good to know. Activation function means positive means, so can you please share the attendance link once again? Amar, please share the attendance link once again. People are asking for it. Okay, basis on sigmoid. Okay, positive means it is good. No, guys, not like that. Actually, I'm confused. Based on the sigmoid. Sorry, activation things means positive means it is good. It is good. No. How to choose bias randomly again. You can choose bias randomly. Initially, because we'll have no basis to choose the bias. So weights also initially there, sir, when you will explain implementation of deep learning. In next classes, guys, we'll try to implement artificial neural network. We'll try to implement this artificial neural network in next class. When it comes to activation function, which one is the most used for hidden layer? Guys, most probably we are using sigmoid, okay? For the hidden layer, sigmoid and the ReLU. ReLU, these are the two popular, mostly ReLU people use and also sigmoid, but we know what are the limitations. Is there any specific optimizer should be used for image data or text data? No, guys, not like that. It's not about the text or image data, it's about the learning of the neural network. When this neural network has a very complex structure, whatever we've seen is like kind of layer 1 or 2. At that time, it is not possible to decide, but when we are dealing with, let's say, hundreds of hidden layers and so on basis of the complex topics, we try to choose the optimizer. Again, it depends on the iterations, how the iteration we are performing, kind of epochs we are doing, and at that time we're trying to saw what kind of loss it is providing. If we are not satisfied with the loss, then maybe we can use the different loss function optimizers at that time. How to choose number of hidden layers? Again, a question. We'll try to understand these things. Then we'll try to understand what are the different networks available. So we'll also understand if you increase the layers, guys. Again, if you increase the number of layers, again there will be issue that we'll try to understand in vanishing gradient descent, and what are the dropout layers also. This is also important topics which are still pending, which we'll discuss, and then you guys will be able to answer that how many layers which should we include. And if you people usually think that if I make a very depth neural network like consists of 100, 200 hidden layers, then it will perform better. That is again a misconception, guys. That I will try to explain these things, that even if you introduce the hundreds of hidden layer, maybe possible that it try to analyze the pattern of the data, but it will have its own limitation again. So what kind of situation can arise if you try to introduce many layers? That is also we try to discuss the things. Apart from that, anything else, guys? Anything else, guys? Any other questions? Just ask randomly anything. So no specific rule on choose number of hidden layer. That you guys, you will come to know when we'll try to go into the advanced topics, that how to choose the layers. You don't have to choose the layers even. When we'll try to create one artificial neural network, customized artificial neural in coming classes, at that time you'll try to understand these topics. Okay, what people have done is they have come up with the architecture, like I spoke about the legends, right? Legends of the Alan Karzeski, right? Jeffrey Hilton, also this guy, another guy, Yoshua Binjo, right? They created this neural network architecture like AlexNet, LeeNet. Okay, in AlexNet they was introduced first LeeNet was introduced, which was having only 5 layers. Okay, previously. Then they try to make an experiment, they introduce more layers. Like in ResNet 50, there are 50 layers. Correct. ResNet 150 is there, where there are 150 layers. So we'll try to understand when we'll try to talk about this ResNet, LeNet, AlexNet, InceptionNet, VGG16, right? VGG16 is only 16 layers, right? At that time, we'll try to understand, depending on the situation, how the networks is performing, or this different combination of the network performing. At that time, you'll try to understand that how to choose the layers, or whether more layers means more accuracy or less layers means less accuracy. That kind of combination and permutation you will try to understand when we'll talk about these particular architectures. All these are pre-trained, correct. All these are pre-trained. Yes, these are pre-trained which are available, so we can directly use them. You don't have to start from the scratch for creating the architecture for this. But for our own purpose, understanding purpose, we'll try to create one own architecture consist of the numbers. Can you explain the role of entropy in the deep learning? Okay. Okay, we'll try to fit in that, but we have many topics to consider. But I will try to certainly accommodate that thing somewhere. What is the role of entropy? But again, guys, entropy is like it's again, I told you, right? I'm giving you like a high level overview for all the things. If you try to go even in bigger, even optimizers will take 1 month, because each working of each and every optimizer and going into detail and going into the geometry of how it is working is difficult, guys, to cover in this session. Since we have a limited time, we'll try to cover only on high level overview. Whenever it is necessary, we'll go into depth. Own architecture is better or pretend in terms of accuracy? Again, depend, guys. Depend. If you want to create your own architecture, it is like creating from the scratch everything, which is nowadays not possible. They already created certain model and they're tested with like a huge data set, right? Like let's say 1 lakh images or 10 lakh images they have created, because whenever you create any architecture, you have to test the accuracy or performance, right? And that performance is not based on simple topics. Like for one object or one let's say category, there are like 1,000 or 10,000 of images. That's how these architectures are trained. Like COCO data set is there, a CFR data, CFAR data set is there, ImageNet data set is there, and MS COCO data set. Apart from them, there are some other data sets there where it consists of lakhs and lakhs of images and data. On the basis of that, they are trained. Okay. So if you try to create your own architecture, you should have that kind of data set with you. How we can justify a particular deep learning algorithm used to give good performance? That you'll come to understand. Guys. You'll try to understand these things whenever we'll speak further, that how to particular deep learning algorithm used for what purpose. This is just the basic artificial neural network. We'll try to understand what is convolution, what is RNN, what are the pre-trained models. At that time, all these questions will be answered. Anything else, guys? So usually what happens is, whenever this algorithm or architecture are produced, they are produced in the huge data set, and you need to have that kind of hardware also, right? I told you guys that whenever you are working with the neural networks, you need to have a GPU with you. Imagine you want to train your model on the, let's say 1 million pictures, right? So even imagine for that purpose, what kind of resources or GPUs you will require and how you will be able to train them. Try to understand this limitation also, practical point of view, guys. So that creating from the scratch, the architect is not a good idea. That's why people go with the pre-trained models usually. And they use the pre-trained model and customize for their own data. How to choose optimizer for different kind of problems. We'll understand, guys. IDEM or RMS prop, we'll understand that. Numeric data as input in CNN. That I will also tell you, guys. Convolution neural network is specially, let me tell you, convolution neural network is specially used for the purpose of the convoluting the images or videos, right? What are the common use cases? I will tell you. CNN particularly use with the images and the videos for classification. Okay, for classification, segmentation, tracking, right? Object tracking, and the particular contour detection, right? So that kind of use cases it has, convolution neural network. So So you what's the meaning of giving then, right? Because if you want to deal with the numerical data and all, you already have a machine learning algorithm, or you can create your own ANN network, artificial neural network. You can solve this problem. But to solve the complex problem, there are different kind of networks are available. Correct? For the sequential data, we have a RNN, recurrent neural network. So where we'll be dealing with the text NLP models or audio inputs, video inputs possible. I hope you guys have enjoyed this session, right? So we were able to reach till optimizer only. Still, we have a very super important concept of web propagation, managing gradient descent, dropout layers, and how to understand how the machine is the neural networks are learning in terms of the gradient descent. So all these topics are super important. And after that, we'll try to implement one neural network, okay, using the GPU, maybe on Colab or maybe on the let's say Kaggle. We'll try to implement in depending on the sophisticated process what is available for us, and we'll try to show you the practical example. Clear, guys? And I hope you guys enjoyed this session as well, because this is super important topic, guys. Once you are able to understand this working, then only you will be able to understand any advanced level of neural network concepts, right? This is the base for everything. So just give me whether you guys are enjoyed it or not, or then we can sign off for the day. Then we can continue tomorrow, guys. Then thank you very much, guys, and just ping me if you enjoyed this session. So on, so all. It's really motivating to hear your feedbacks. And then we can continue tomorrow again. Assignments we will give you whenever I'll show you a neural network. We'll try to create our own neural network. At that time, I will give you assignment for the same. Thank you. Session was very informative. I will give you one particular task, and using that task, you can create our own neural network, and then maybe you can implement that. Attention is here, guys, again. Yeah, thank you very much, guys, and then see you then tomorrow. Got clear picture. Okay, thank you, guys. Thanks for your feedback.